as well. So I'm very excited to learn about everything that you'll be teaching us tonight, and I hope the energy is the same throughout the rest of the audience as well.
Oh my gosh, seasoned DevOps engineer. I like it. I'm being hyped. So yeah.
It's all about community and uplifting each other here at
Yeah.
WTM. So
So what about the others? I just see everybody. I love if you just see me right, you know what I'm into. Faces, communication. Let's keep it very, very friendly. There is nothing like I know more than you or you know more than me or I want to learn. You all are here for a reason, and I believe that sometime in the future you're going to serve me. So at the moment, let's interact with each other and yeah, break the ice.
hi.
We're running on time. I don't know what the drill is. If you're expecting more participants, or you always give it like 5 minutes before we kickstart. So just let me know what I'm to do, and I'm here for you.
Perfect. Perhaps we can wait for a couple of minutes to in case more people would like to join. But until then, shy people, you're always welcome in the chat to introduce yourselves. The floor is yours.
Well, I'm going to do what I love doing, and I'll just invite Aida Aman. Hi, Aida.
Hey, Indah. I was going to be the icebreaker, to be honest. You just mentioned my name.
Oh, nice.
All right. Hello, everyone. My name is Aida Awan. I'm a front-end developer and also a software engineering student. I'm also part of Women Techmakers, a proud member, to be honest. I really love Women Techmakers, and thank you so much, Indah, for being here today.
My pleasure. My pleasure, Aida. I'm so glad. Software developer. Wow. I love when women are taking over, right? I love when women just like because when a woman is involved, oh my gosh, you feel so relieved. You say, "Oh,
Yeah.
thank God there's a woman involved," because you know, you know,
Little.
yeah, we have like this special sense of everything's going to be okay. I don't know for those of you who have siblings or even mothers. Imagine when you come home and if you're married, your husband is like, oh, thank God you're home. This is that, this is that. So just like giving it to you without even asking you how you're feeling, you know? So yeah, that's the superpower that I love. And I really so admire women and men as well. These are amazing men here. So whoever wants to challenge me should come up. Any man who believes in their capabilities, come up here and let's have that.
I don't think they will dare, though.
Oh, they wouldn't. I know they love challenges, so I'm giving them a good one, you know, but behind closed doors. So, wait, Aida, did you just say you are in charge of the icebreakers? Did I hear you correctly?
And the chat?
No, did you mention that you are in charge of the icebreakers? Do you have like something for that or
No, no, no. I was just going to introduce myself.
nice?
All right, that was incredible. I believe we have our average number of people who have joined, so I believe it's best if we dive in. Over to you, Inda.
Oh, thank you so much. Quick question: where is Meron? Maybe she's named differently here. Where is she? The person I was communicating with.
Oh, I'm not quite sure whether she has joined, but she will join us shortly.
Ah,
She may
okay.
have connection issues.
Oh, connection. Please just give me a few minutes, please. A few seconds, not a minute.
No worries, take the time you need.
Okay. So I'm ready to go. I don't know if to share my screen now, or is there a particular methodology thought about? Okay.
You're welcome to share your screen, I believe. It works.
Do you see my screen?
Yes.
Let me go full mode. Let me get fuller than this. Presentation mode. Hold on.
You can click on the slideshow button.
Oh yeah, nice. So, in 3, 2, 1, when the video show now, action. So, ladies and gentlemen, I'm so happy and thrilled to be here. I think the last time I had something to do with Ethiopia was in March when I had a transit in Ethiopia to go to my home country, Cameroon. So I know that there are very, very beautiful people there. And I just feel more prettier being here virtually with you all. Secondly, pleased also to be here in a professional terrain and hosting the seventh or presenting at the seventh International Women's Day. What's it again? I'm sorry to be misquoting. Mentorship. Please correct me if I'm wrong.
It's a mentorship series named From Design to Market, Week 7.
Yeah.
You got it right.
Week 7, from design to market, mentorship, week 7, let's go. So our topic for today is on DevOps. So I'm going to be taking you all through the journey, why DevOps and why not DevOps. So it's some kind of like, why it and why not it? So by the end of it, you understand why DevOps. And next slide. Before we continue, let's do some icebreakers for people that are really like tense, or let me just apologize for the inconsistency in the front size. Is the message that matters. So let's just go ahead now. The first question is what animal, you all can read, what animal best represents you today and why? I'm going to wait for a response or in the chat. Yeah, Aida.
So, the coca, if you know it, because uh, so as a research say that coca is really excited, and I'm really excited for this workshop.
I don't know what an animal is.
Wait, let me write it down in the chat.
I don't still know what that is. If I need to Google it.
You can.
Coca. Oh, really cute.
I know.
Wow.
He's just the most excited animal in the world, so I'm really excited at the coca.
Oh, nice. Oh, I wish I could be excited as that, but I would like to be like a chameleon myself because I like to regulate myself. Here in Germany, it's really like almost 40 degrees.
Hmm.
What animal regulates the temperature? It's not a chameleon. Chameleon changes colors. So I like to be able to regulate my body temperature if I could. So whatever animal does that, that's me today. So, so who else has something? Yeah, Hildana.
Okay, hi.
Hey.
Okay, I would represent myself as a cat because, first of all, cats are adorable,
Yeah.
but also they're well known for like setting boundaries. Like they're very specific with their boundaries, and I feel like I am that person. So I would say cat would represent me more. Yeah.
Nice question. Question. Do you have children?
Mm.
Okay, so just enjoy those boundaries as of now. Because once they come, they are gone. Right. Nice, nice. Who else? Who else can say something about an animal that best describes them? Yes, Gabriela. Yeah.
I think I would consider myself a very hyper rabbit today because it was filled with many tasks and it's still the evening. So I was very much on a high energy today.
That's nice. I love that. I love that.
Yeah.
So, nobody else wants something. You can put them in the chat though. So let's really have a moment later on to enjoy what animal best represents you today and why. So let's go to the next one. What's one of your most favorite recent memories? I'm going to wait. I'm going to say mine. This afternoon, I had amazing lunch. So I had fun eating. And when I sit to eat, the sun is rising, not rising, I can see the sun. And there's a vineyard. I live in a village like area. So it's really, every day is a good day to be outside. So that's my most favorite, or my most favorite recent memory. Okay. Yes, Aida.
All right. So yesterday I had a virtual meetup with ALEX students. So most of them with Nigerians, and I get to meet them yesterday, and they were really so wholesome, and they were icebreaker questions too. So yeah,
Ah,
that's the more I enjoyed the most.
nice. Nigerians are really awesome. Africa
Yeah,
is like a great, great place to be. The world's a
I
good place. Let's just make your environment awesome then. So
yeah.
next and last, sorry again for the indentation. What book or movie would you like to live in? I like to live in it. Let me go ahead. I like to live in this. Have you watched the Kung Fu Panda? It's an animation. Oh my god, I'd like to be Poe's best friend. I love Poe. Poe is like so amazing. Even the world is crumbling down, Poe will find a very one thing to be positive about. So yeah, I love that movie. I can watch it anytime, any day. It just lifts up my spirit. My kids know that as well. If I'm sad, just put on Kung Fu Panda. So yeah. So anyone else? Okay. Yes, Aman. Oh, nice. Someone different. Yes, Aman. I see you, Aida.
Oh, okay. So the movie I would like to live in is Titanic because gentlemen like him are real these days.
Yeah. Do you know what spoiled the movie for me?
I'm
Is
always
behind the
in
scenes. Behind the scenes ruined it for me. Behind
it.
the scenes, they like shows Ronaldo on like a broken door. He was just like hanging there. I said, "Oh my gosh, I almost cried out all my tears because of this movie." And this is what was happening. Even though we know it's fictitious, right? But they like
I
drag us
know.
into their world. Yeah, I love the
Mhm.
movie as well. There's a part two coming up. Heard about it?
Oh, really?
Yeah, this part two is in the making. So let's wait to see how
Oh, I'm
it
excited.
goes. Yeah. All right. Thank you all for breaking the ice. Now let's get down to the juicy parts. Now, who here knows about what DevOps is? The real reason for DevOps and the shortcomings that happen, the story behind DevOps. So let's go back to the beginning, right? Because we know like software development life cycle. In the beginning, let's say you want to create a banking app. That's the most simplest example. You want to create a banking app, and in the banking app you have like the place for service, you have the place for questioning, you have different landing pages for different things that have to happen. And in the beginning, you have to set all of these requirements. And we need this, we need that. It has to be designed, it has to be implemented, it has to be tested, and then we need to get all these questionnaires, all of these things together. So traditionally, you see on the right hand side, I don't know, my left, your right. On the my left hand side, you see the traditional waterfall model, which means you start on at anything you want to do. You need to get the requirements. If you're cooking, you're going shopping, you need to find out that everything that you need is on the list. Everything you need is provided for. So traditionally, we had a linear sequential process, which means one has to go on before the next. You have to get the requirements, then you get the list, you get everything, you get the planning, everything. And if the requirements are not, it's not complete, you can go to the next step of the process. Then later on, they found out that, oh my God, which means the design team will have to really wait for the requirements. So you can be paying designers who are waiting for like 3 or 4 months for the requirements before they start working. So you see that they are wasting resources. Now, what did they do now? They shifted with time, they shifted now to the agile methodology, which is much better than the traditional waterfall. The agile introduced iteration cycles, which like sprints, right? Which means we first do this sprint and often remain between developers and operations. DevOps bridges this gap, which means you have this sprint, and if you're not satisfied with this sprint, you can go to the next. You can skip between sprints. So that's the benefit of doing agile, because you can do several things simultaneously, which is also better than the traditional. Now, where does DevOps come in? DevOps comes in the sense that it merges both. DevOps is a transformative approach. DevOps is a blend of philosophies, practices, and tools. DevOps is like a mixture of everything in one. With DevOps, you can do all of those independent of each other and come back to it. You keep iterating and shifting and moving simultaneously till you arrive at the best decision. Even after you have arrived at the best decision, after deploying your app, you can say, oh my gosh, I'm not really satisfied with this. Let's go back again and add an additional requirement. So you see that DevOps, you are developing, the DEF is developing, and the operations. DevOps, you are developing and operating simultaneously and getting better. So it is like it functions as a catalyst. As we all know, a catalyst is something that speeds up or speeds up a reaction, but doesn't take part in it. So DevOps is like a catalyst in that sense, and the DevOps unifies developers and operation teams. In in the slides to come, we shall understand what differentiates developers or development from operations, and how they together unified makes the process more efficient, for lack of a word. Yeah. So let's move now to the next slide. So there are some basic principles of which DevOps is built upon. As I just said earlier, we talked of a continuous improvement, which means when you go through it and you can go again and improve something or reduce something. You can go both ways. And DevOps ensures for security. We shall see how secure it will be. And since we're working with development and operations, it's a culture and collaboration. And there is like one, I don't know if I can say hell, yeah, hell of an automation going on here behind the scenes at all levels. Because we want to make sure that there is little or no manual intervention apart from we the humans, and everything else is being automated. So what's the next thing? So, okay, these are just more benefits of DevOps. You will have these slides later. So we'll see like increased efficiency and accountability, competitive advantage, reduce manual errors are really reduced, improve quality and reliability, faster and continuous release. Yeah, now, this is a DevOps life cycle. You see, you start from, let's say, we start from planning. This is the best place to start from. And it's the initial thing where you have to plan. When you plan, you code your plan, you code it. And we should not really complicate coding. Coding is a series of steps, systematic steps that defines a process. Like I can code my way to the grocery store. I say first, step one, get up. Step two, put your left foot on the ground first, not the right foot. You put the right foot, it's an error. Step three, put on pants. Step four, brush your teeth. All of those things. Those are a series of steps. Get out of the house, get your key, enter the car, drive to the store. I've coded a series of systematic steps to achieve a particular goal. So people just, yeah, and that's a complicated coding, very complicated, and it's very simple codes. So code is just like, yeah. So when you plan, you codify it. When you've codified it now, you build it. To build it, when you build it, building means you put the steps. You cannot get up and go to the store before coming back to brush your teeth. You have to get up, use those steps. You build them such that it should be stable. And you test. You have tested and it has succeeded. You say, oh yeah, I did it good. You release. Release, it's almost like, okay, I've done it, I've released it. Now they deploy. From deployment, operations does its thing. We can talk about it. Then monitor. When you monitor and see that, oh my gosh, we could do it better. You could take the shorter cut to the market. Then we'll go back again to plan and make it better. But say, okay, I won't take the longer road, the shorter road, and I'll see the benefits. Do everything again, then you monitor. A monitor for monitoring gives you like an overview of what you have done, overview of the whole process. You can be building and say, oh my God, I made a huge mistake. Instead of doing this, I did that. Then you go back again and adjust the plan. So you see, that's a DevOps life cycle, development and operations. The life cycle, it never ends. If you have any questions, please put them in the chat, and the amazing ladies will take care of it, or just call my attention to anything that needs my further explanation. So, okay, let's look now at the benefits of DevOps methodology. 10 times faster delivery, 50 times fewer failures, and 200% more collaboration. So all in all, DevOps has the juice. Now, we can be asking ourselves that, how do you even start with DevOps? I know what DevOps can do. I know the benefits attributed to DevOps. Now, where do I start from? You have to start from having a machine where your application is going to run on. Your application can be anything. Let's just stick to the banking app. Your customers are remote, and you have a remote customers. Who else here knows what a virtual doesn't know? Let's go the other way. Doesn't know what a virtual machine is. So if you don't know what a virtual machine is, you will know soon. So, and these virtual machines are like computers in the cloud. Yeah, computers, yeah, in the cloud. And the three biggest providers of these cloud environments, we have AWS, of which we use in our company, and I'm basing this on AWS. We have a Google Cloud, we have Azure, we have IBM. There are some little other players in the cloud environments. We have Northflank. There are a few of them. If you just ask the 10 biggest cloud providers, you'll see these four in this order. Then the rest come in no particular order, to my best of my opinion. So we shall be using AWS to demonstrate this example, even though there won't be a lot of hands-on, but anyone who has Google experience can still do it at your own pace, at wherever you wish to practice on, or wherever you're currently practicing on. So let's go back here. What do we do here? Here is for if you have an account and you say, okay, my banking app has to have memory, CPU, storage, security, high availability. These are basic knowledge that each DevOps engineer should possess, which means that making sure that you have the right tools, the right capacity, the security, such that you can be able to work on your application seamlessly in the cloud, no matter what the provider is. So assuming we took AWS and we did that, now you have your virtual machine, and on that machine, let's say the application is already running. How do you interact with it? How do you make changes to it? How do you even start? You say, oh my gosh, something is wrong. How do I fix it? Or how do I even start working? That's when we have Git. Git is like irreplaceable in DevOps. Anybody doing DevOps, in cloud engineers, they must do Git. They must have the foundational knowledge on Git. And the Git is like a source code management, because the application, the beginning is a code. After you have planned, right? Your planning is fine. You have the code. Now you have to manage the code. All the deployment, everything has to be done with a tool called DevOps. Git. Now, there are steps to install Git. This is a link here, it's clickable. Here you go here, you click on it, and you can install Git on your machine, your laptop, your physical laptop. Install it there, and then you can use the commands to manipulate or to work on your file. Let me just say this, for a proper understanding of DevOps, one needs like 4 months to understand these tools, play with them, and have some hands-on experience. This session is just like a storytelling on why DevOps, right? Why DevOps and tools to use for DevOps. If you really want hands-on, there should be something like a 6 weeks, 8 weeks bootcamp where the hands-on is going to be done there. But this one is just like you to understand what it is. Because I feel a little bit guilty that I can't really show you at the back end how Git works. So Git, source code management. And why do we use Git also? We use Git because it tracks changes. let's say you're working on your, maybe I'm talking for the next slide. Let's go to the next slide and see what's there. Oh yeah, nice, good, yeah. Now, assuming you already have, yeah, your EC2 instance, which is a virtual machine. That's the name a virtual machine is being called in the AWS environment. You have created your virtual machine. You have given it an an image. You have given it a capacity, CPU, memory, attached an elastic IP to an IP address, which means that a public IP, something that you can use to access it on the URL, everything. Now, you want to work on the code, on the application, which is the code. You have to build it. This here is like, who knows what GitHub is? Or who doesn't know what GitHub is? All right. So GitHub is like a repository where you save the code. So, okay, this is the code here. Anybody who wants to work on this code has to come and take the code from the remote repository. And the repository can be GitHub, can be GitLab. We use GitLab. It can be Bitbucket. There are many repositories, like a warehouse. You go there, even there's so many samples there. Let's say you want to just build a different app. Let's say you want to be an AI agent that can break dance, and somebody already has this code in the Git repository. You have to go and collect it from there. You have to pull it down. It's in Git, you pull it down, and you have to pull it down with a Git command. And you see everything is called GitLab, GitHub. A hub is a safety where we save things. A lab is also where all your equipment are. And the first way it has Git, which means I have to use Git as a source code management tool. I don't know. Yeah, that should be clear by now. So when you go, there's some commands that you say Git clone. We have to clone the code from the repository. You clone it here into your working directory, in your local file, which means you have to bring it down to your own computer. When you have brought it down to your computer, you need to have like some little bit of Linux. Without Linux as well, you can't really walk around. It's impossible to do anything without it. And Linux are the commands to manage your file management. Let's say you want to see that, okay, I've downloaded this or I've pulled down this repository. What's in it? You can know what's in it with the git commands. And the git commands you can do like ls. Ls is like to see what's inside. Ls minus la to like see the total thing. You can give it commands. You can do all type of things communicating with it. So that's what we use Linux to communicate or to interact or to make changes to a file that has been to a source code, which is now in a file or in a directory or wherever the case may be. As I'm saying, I wish I could simplify this easier with examples, but this is the easiest I can go. I'd love to do some hands-on, but in 90 minutes, we can just do as much as explaining the whole process of a DevOps from ideation to market. So now, you bring it to your working directory, you make your changes. If you have changed a file, the file changes to red. You have to save the file, you commit the file, and you push the file back to your, you push the file to the remote repository, back to where it came from. And then the changes, oh my God, I really hope I'm not doing too much here. So, okay, now let's go closer to the working directory. Please, I would also love questions. If there's any question, please ask. In the local working directory, it's like it's your local machine where your Git project lives, and the Git project was pulled down from the remote repository, and it contains tracked files. Tracked files are files that have been managed by Git, and then you have untracked files that is changes that you made, and you have not yet committed. Committing a change means that saving the change and letting the change go into the file, go into the code. But again, know that there's something called uh, Git ignore. Git ignore means that not all changes are going to be pushed visible. Some changes have to be ignored. If not so, your code will be a little bit messy, and not all dependencies need to be pushed or need to be visible. So now, why is it important to have the local working directory? The local working directory is also important because you can have many people on your team, and you cannot work centrally on one file. It will be too messy. So everyone has to work individually, locally. If you're remote, that's also a reason. Work locally when you take down a file or a source code. It's called the main. You have to create a branch. You branch from the main in your local. You make your changes. You can delete. You can edit. You can add. Then whatever change you made locally, you have to do the git add, git commit, and you push it. So again, when you push the changes, they can also it can lead to conflict. But the easiest thing in that Git has it's like a 1 week thing to know Git on how to resolve conflicts. You're working in a team and everything. I still babble over some rebasing. Git rebase is not really my best friend, but I'm trying to get a hand on a hang on that. So now, if someone has been asking themselves that, okay, if I'm pushing it, if I'm pulling it down to my local machine, where, how do I work with it in my local machine? In your local machine, you need to have like a working directory, because you can't pull it into your WhatsApp or your anything. You need to have like a working directory where it is designed. It has all the dependencies and all the provision to handle code. So I personally use VS Code. I don't know anyone using any other IDE apart from VS Code. There's some cool ones out there. But I prefer VS Code because of its dependent numerous extensions, which makes life easy. And now Copilot, which does most of the brainstorming or the troubleshooting for most people. Most people, I mean me. So, okay. And any questions so far? Is this really clear? I love some little bit of interaction. Anything going on? Because I feel I'm talking. Oh yeah. Oh nice. Good. I like that. All right. So if you have noticed, I'm an interactive person, so questions are really like my best friend. And now let's talk about the automation engine. Where does the development start and where does operation take over, like the DevOps? Which part is called developing and which part is called operations? Again, or other ways are to say it a different way. Which part is called a CI and which part is called a CD? Who knows what a CI/CD pipeline is? Are there any DevOps engineer in the house? Just give a like. A like. If you know what CI/CD is, and if you know, yeah, DevOps. Oh yeah, good. Okay, so, nice. So CI stands for, you can already a continuous integration. And what are you integrating? You're integrating the plan, the code, the build, and the test. That those are the that's the stage where the change takes place. The change takes place there. This four aspect is a continuous integration. You're like molding it. And when you mold, you have to release it for deployment. Deploy, operate, and monitor is a CD part of it. So these are the stages of a CI/CD pipeline. These questions always comes in an interview. It's been a while since I've had an interview, so I don't know if it's still a valid question though. So they always ask for the difference and the tools you use for CI and the tools you use for CD. So, and we shall talk about those tools later on. So now I've said that we are deploying applications, and those applications can be a container image, it can be like a database, it can be like you can just do little changes to your existing applications and you deploy it. Any single change that you can do, deploy, release, and deploy takes place in the CI/CD. Even when you're an image, updating an image, the change has to be deployed. Whatever you change has to be deployed. The change is addition, subtraction is a change. You need to deploy it. Now, I think we shall talk about this later. Let's skip this slide at the moment and skip this and skip this. Now, who knows what Docker is? Okay. Oh, nice, nice, nice. Nice. So, before we go to what Docker is, I want to do this now. Yeah.
Let's give her a few minutes to return.
Ekonomi I can't hear anything. What happened?
Oh, can you hear me?
Yes, we can hear you now.
What
Yes.
happened? Did I meet myself? Oh my gosh. So, what was the last one I said?
We stopped on deploying around CI/CD, and before we proceed to the rest of the presentation, a couple of questions were sent to the chat. So I think it would be best if we could clarify those before
Sure.
moving on to the rest. Yeah.
Yes.
Okay. So Naomi did ask what a container image was, and a
Oh.
couple of others were trying to answer it until you returned. So I believe it's best if we got your input before we proceed.
Oh, an image is like an application. You can have the image to create a database, an image to create a web server. In Nginx, you can have an image. All An image is like the blueprint of an application. Does that make sense? Let's say I want to create um, a website, and I want to use a particular Nginx. I want to use Nginx because I need traffic. So, and I need to use an Nginx image. So that's how easy I can define an image. You can have an image. Let's say you want to create the simplest one is a database image. And what's the difference between image and container? Uh, um, if you have a container, oh, I'll clarify that. I just wanted us to understand the birth of containers before we go back to Docker. Because when I talk about Docker, some of these questions will be answered, right? And if not, please, I'll come back to the questions. So I want us to just understand how we came to containers. Because the limitations of the physical machine, the limitations of even the hypervisor to create more virtual machines led to the led to the birth of containers. And for containers, and for you to be able to create a container on your hardware, you needed an operating system and a container runtime. Without this runtime, containers would not be created. You just see like a runtime has to be present. And when the runtime is present, you have the container image, the bin, the binaries and libraries, like the dependencies, the things that hold it together. So how can I best explain this? You always have binaries and libraries. Those are things that come along that help to maintain, to sustain the application. Without binaries and libraries, those are some building blocks for the application. It's there is not really like a difference. They work together. So let's go back. Let me go back now to what is Docker, and let's go back to Docker. Okay. Okay. So now, definition. Docker is an open source platform that packages applications and their dependencies into containers. The dependencies are the binaries and lib. Those are dependencies. So if that answers your questions, I'm glad. If not, with more time, you'll get to understand what those are. I just went a few slides ahead, but these questions are valid because if a chunk of the knowledge on why Docker and what Docker is depended. What's the difference? Okay, okay, I'm reading the same questions. So, and what's the purpose of Docker? It's to simplify. It simplifies creating, testing, and deploying applications by ensuring that I'm just reading that they run the same everywhere on a laptop, server, or cloud. Because imagine that you had your operating system was Windows, and I'm using Mac. Let's say I'm a Gabriela is using Windows or Linux. the dependencies can work on my machine and it's not working on hers. So at the end, the application is working, but just that the setup of each operating system hinders the application from working unanimously. So that's the main purpose of Docker, is that you build once and run it everywhere, which means that it doesn't depend again on the operating system. Let's go back behind here. I'm sorry, I need to do this again. You see here, they needed the applications were on the operating system, and their applications, they have hypervisor, sorry. Here, you see how the applications again directly with the operating systems here. Operating system application. But here, what do you see? Operating system container runtime. You have the containers. So they are not directly related to the operating system. So that's the main reason, that one of the main reasons, not that's the only main reason, one of the main reasons why we use Docker. Yeah, simplifies creation, testing, and deploy applications by ensuring they run the same everywhere on a laptop, server, or cloud. You build once and run everywhere. So next thing is that, okay, this is how um, the nomenclature, the architecture of a Docker looks like. Again, all right, someone is asking me what an image is. These are all images, and the images reside. Some people everywhere, experts, already said that, oh my God, if you want to create an application with this and these features, I already have the blueprint. The blueprint is called the image. The image is saved somewhere called a Docker hub. You don't need again to go and be creating the application from scratch. You just go to Docker Hub. You have the public repositories and the private repositories. So you go to Docker Hub and say, oh my God, I want a database for my thing. Or I want Ubuntu to learn Linux. You go and pull it. These are the command. So this Docker client is your physical machine. This is your physical machine, and you don't interact with your physical machine, you interact with it through a cloud provider. This middle part is a cloud provider. It can be Google, whoever it is, AWS or what. This is a cloud provider. So you already have the Docker installed on your physical machine. You go to the hub, you say you search for the hub and say, okay, this is the image I want. Oh, I'm thinking of if I could have created an image, an example, but no worries. I'm here. You can send me a message later on and we can talk about this or create something very light for you. So once you have the Docker client, you say Docker pool image name. You put Docker pool a database, Docker pool this, Docker pool Ubuntu. It pulls it down to your local machine, to your client. Then when you have it now, you say, okay, Docker. Yeah, but it works my way. I know, right? That's the typical error, yeah. So when you pull it now, you have to build it. And when you build it, you run it. When you run it, you start it. These are all commands. I'm telling you, the Docker is a course on its own. And at the end, I'm going to share you some useful links for beginners. Docker is a course on its own. I'm just explaining to you the philosophy and the theory, the reasons, the raison d'etre behind all of this. So this is just a basic architecture. So you can decide to build your image from scratch, or you can decide to customize an already built image. There is also in-depth on that. You can say, okay, from this base image, these are called base images. You can manipulate the base images. From this base image, add this, do that. That's a Docker file. People know about this Docker file and everything. So it's a shame we can't go deep into this, because if I go deep into that, that would be like a rabbit hole. We shall be here for hours. So now, this is another simple image of the Docker architecture. This is a sign that you are working as a client. This is the host. These are your containers, and the images are in the containers, right? The images have been built in the containers, and for the image here, you pull the image from the hub in your container, and then you run it. So please, if there are any questions there, please call my attention to it. But I believe that with time, we shall get to understand a little bit more on why of all of this. So now let's define some terminologies. I think I might have defined them in the passing. But let's say containers are lightweight, isolated environments that include everything an app needs. Um, you know this, like you go to the store to, you say, I don't have the time to cook, but I want to eat like some, let's say, some stew. I want to eat stew. It should be peppery, or it should be sweet, it should be salty, and someone already has all of that compacted together. That is like an image, right? Put the image of what you want, the description you want, and then put it in a plastic, in a Ziploc bag. That's that. The Ziploc bag now is a container. Yeah, your image is in your container. The image is like the food you want to eat. They have packaged it now in a container and giving it to you, that take, go and heat it up and eat. So that's like the sense behind containers. So the images are templates used to create containers, right? So you cannot have an empty container. You must have something in it, and it's an image. And the image depends on what you want. Is it a database? Is it an application? Is it a storage? Whatever it is, we go to Docker Hub. Maybe I can just pull out Docker Hub here and show. Let me see. Docker Hub. Excuse me. It's a little bit not here described here, but if you go to Docker Hub, I'll put it also on the slides. You'll see all types of images that you can put, that you can have. Then you have the Docker engine, the core software that runs and manages containers on your system, which means that when you come back home, you need a pot to heat your food on. I'm taking the most basic example here. So, and why Docker works? Because it's portable. Containers can be shared and run on any machine with Docker installed. So exactly here, now it works on my machine. Yeah. So anyway, it like eliminates that question. Oh, or eliminates that problem, I can say. Yeah. With and virtual machines. With containers, you can create and destroy at will. But before you destroy a virtual machine, oh my gosh, depending on what is inside, and you have to like let everything detach, and the speed fast start up and fast shut down, developer friendly, simplifies workflows on CI/CD, and also simplifies some collaboration. Now, you see how sweet Docker was now, but it also has some shortcomings. What can go wrong? We already have like the image and everything. You see how containers can really be very simple to deploy, and the portability and the rest. But again, we come now to still the limitation of CPU, memory, and disk space. At a different level now, it's always there. Then you have manual management. You have to scaling, updating, and monitoring containers across multiple servers is complex. Because if you want to have like a database, an application, a storage place, everything, like if you want an application with different images, it's a little bit complex to manage, and you have limited orchestration. It's very difficult to scale. It's challenging to scale. That's when Docker Swarm comes in, and the rest. Docker Swarm is used in orchestrating, which means that, okay, somebody says that, yeah, I created my applications. I'm using like 15 applications on Monday morning, but on Friday evening, I needed to scale down to 5. Now it's a little bit complex with it, so the scaling is challenging. The network complexity. because if you have many containers, they have to communicate with each other. They have to be secured. Some should not have access to others. So all of these affects or reflects negatively on Docker. So, and now this is where Kubernetes comes in. Kubernetes is also an open source platform for automating deployment, scaling, and managing of containerized application, which means that Kubernetes is an extension of Docker because it still deals with containers. We need Docker to create the containers, and we need Kubernetes to do what to manage it. Kubernetes manages it. You can scale up, scale down, self-healing, and the rest. And this is really a great tool for any business that wants to scale, any business that wants to improve network and everything. Kubernetes is just the way to go. So that's the role of Kubernetes, orchestrates containers and everything. So Kubernetes has a series of functions: automating, self-healing, load balancing, auto-scaling, rolling updates, and rollbacks. I have a presentation I did on just the power of Kubernetes. Just this slide had a whole presentation for an hour. So I thought of including it here. We have just made our session really longer. But again, Kubernetes is huge. But just know that Kubernetes manages containers. So yeah. Now, how they work together. Docker builds best for building and running containers. Kubernetes best for managing containers at scale across clusters. So together they provide a modern solution for developing, deploying, and operating applications in any environment. Does that make sense to anyone who has questions? Okay. Now, I just had this example here to show how Kubernetes and Docker work together. So Kubernetes, Kubernetes work with what you call YAML files, and it has four main components. You have the API version, the kind, the metadata, and the spec. So here you see that this is a deployment, and it's using the Nginx, and it's an application. So you see that it says replicate three. I want three replicas of this, and it's using the image. This is the container and the image in Nginx, Docker image from Docker Hub. It got this image. Without this is useless. So this is where Docker comes in and works with Kubernetes together. And again, you also have now the service. If you just create the application, it's good to create the application, but how do we access the application is called a service. So Kubernetes also deals with the management, the accessibility of the container, of the application built in the application, which is in the container. Okay. And this is called a pod. So you have an image in a container, and a container resides in a pod. If you hear anything of a pod, if you hear a pod, think of Kubernetes, and the pod has an image. All right. So this is just theory. You have I forgot the title. So we have the Docker's the role of Docker, the role of Kubernetes, and the workflow. Without, now I'm repeating myself. Without an image, we can't build a container. And without a container, Kubernetes can't work. So these are the dependabilities of it. And you know that Kubernetes, it provides, when the application in the container is being deployed through a pod, when Kubernetes provides a service how you can access the pod. the application in the container in the pod. All right. It's a little bit tricky, but if you understand that, fine. If you don't, it's still okay because it takes time for such knowledge to sink in. As long as you understand the reason why, how they are connected and why they are both important, that's the message I want to pass over here. That Docker and Kubernetes are like this. Okay. So we already talked about this. I wanted you to understand all of this, um, um, why containers, and because we have containers, we need Docker, and because Docker falls short, we needed Kubernetes. All right, that's good. So let's talk about the architecture of Kubernetes, how Kubernetes looks like. So you have like, now this is, okay, let me explain it differently. You have a pod, and in that pod is a container, and in that container is an application. Now, where does the pod reside? The pod resides in a node or on a machine. And AWS, using AWS, the pod resides in a node. So these are like pods. And in this pod, you can have 3 containers, you can have 1 container, you can have 2 containers. And all of these containers, as we saw, they depend on Docker. So they have been created. Now, how does Kubernetes master? Kubernetes has 2 components. It has like the control plane. They changed the name for master. Sorry about that. Yeah, it has the control plane and the worker node. So this control plane has these four aspects. You have the API server. The API server gets information. The API server communicates with the kubelet, and the kube proxy takes care of networking, and the kubelet communicates with the API server to say, oh, this is the state of this worker node. This is the state of all of the ports. You communicate with the API server. Now, what is this scheduler? When, let's say, we still have capacity and more applications are supposed to be created. Now, the scheduler says, let me go around and check on our architecture. On which pod should we create that container? So that the name scheduler, it tells you that, okay, we still have capacity here. So we can place an extra container here. And the scheduler is in charge of that. Now, we have also the controller manager. The name itself speaks for itself. It goes ahead controlling the state. Is a state the desired state? So you always make sure that the desired state is always attained. Then we have this also, this etcd. It stores data in key value pairs. It says that, okay, all the data pertaining to the setup of this architecture is being stored in the etcd. And the etcd communicates with the API server to like all of them work together. So this is now the user. How does the user have access to this? There is a, how do you call it, an interface or a client called kubectl. You have to install it. So when you say kubectl get ports, it tells you that, okay, we'll have 3 ports. You say kubectl get nodes, it will tell you that we have 2 nodes, 1, 2. kubectl describe node 1. It will tell you that in node 1 we'll have this number of ports and everything. So as you just see, it's like it interacts with the worker nodes and the services. Questions? No? Let's move ahead. Okay, now we have seen that we've talked of Docker, we've talked of why we need virtual machines, why we need containers, because virtual machines are really slow when it when it comes to application management. Why we need a Kubernetes, because we need to manage the applications which are in the containers, which contains the images. Now, let's come back. Let's take a step back and said, all right, ask the question that what if we wanted so many nodes, or what if we wanted so many of other components that don't have anything to do with containers? How do we manage them, the infrastructure? So, do we always have to configure the infrastructure from scratch? Let's say if you want to build an EC2 instance, or like many of them, whatever you want to build, do you always need to do it manually? So these are the two scenarios. If you do it manually through the AWS Management Console, it's inconsistent, you can make mistakes. But if you do it through an infrastructure as code, uh, who knows what that is? Infrastructure, or who doesn't know what that is? An infrastructure as code is when you like have a template. Let's say I need, let me see, do I have it here? Okay, good. This is an example. Any one of you here who already created an EC2 instance on the AWS Management Console knows that it had 8 steps. But now AWS has simplified it in such a way that you have like 3 steps, but infrastructure as code is easier. Because you go, and the good thing about the infrastructure as code is that it doesn't depend on a particular platform, which provider, what I mean. It is cloud agnostic. That's the word they use for it, which means you can use it on Google, you can use it on AWS, you can use it on Azure, IBM, or whatever. So provider here is AWS. And you sell it, you tell it that I want to create whatever this application is in US West 2. And the resource name is this, and this is the AMI, the Amazon machine image. This is the instance type, who tells you the capacity, the CPU and memory. T2 micro is the smallest. And I wanted to have this name. You will just do like that. Infrastructure as code got you covered. So it does several things. You can define a whole module. Terraform is also, again, a complete course on its own. There's a very good course on Udemy. It's a 30-hour course. You go through it, you're good to go with Terraform. So there's nothing here that is really like you got it right. You need to practice, understand why, then it will give you the drive to want to do it more, or to want to learn it deeper. So we have talked of infrastructure as code. Now, what's the key function, let's say the key principle of infrastructure as code? You write what your infrastructure should look like, right? So let's say in your management console, you have given something like, I want it to have this machine image and this, but your Terraform, whatever is in Terraform is what will be produced. So it overrides whatever setup you have in your management environment. I don't know if that makes sense. So which means that it is a declarative, and it is versioned, and it is immutable. It runs the same several times, doesn't change. All right. Now, these are other further principles. It's automated and repeatable. Provisioning new environments, which means you can decide to have different setups in your developer, your testing, and your production. In DevOps, we have like different environments because we don't want to take something that you haven't really tested to production. So you develop it in an environment, you take it to the testing, from testing, you take it to production. And the pipeline, the automation pipeline runs all of these jobs. Now, how do we use infrastructure as code in DevOps? Let's say, for example, you have this is really the example that I showed here. This is how it's been used, but I'll just go back to the slides again and go through it. You want to have an EC2 instance. You want to have a VPC, a virtual private cloud. That's what it stands for. You want to have a relational database. You want to have an IAM role. You don't need to go through the cloud provider and manually provide all of this. No, what you do is you use Terraform and you define it. I want a VPC in this particular region with this, and this. And again, on the same template, you give a few lines. And again, I want you at the same time to produce me a database, and I want an IAM role. I want this. It can be as long as you want it to be, as long as you have the capacity to run it. Once you have defined all what you want on the template, a single main.tf, when you define all of this, you go now to Terraform init, that a couple of Terraform commands that you have to go through to provide to like yeah, to provision all what you have what's what I'm looking for, or what you have requested for lack of words, on your template. Now, infrastructure as code, it runs as part of your pipeline. Let's say you wanted again, and it can run parallel to Kubernetes. Let's say if you want to create 2 worker nodes, and those worker nodes will have some particular things and everything, you can use Terraform to create those worker nodes and everything involved. I don't know if this makes sense, but it's making sense to my brain, and I think that I will make it simpler with examples again, time. Now, how infrastructure as code is used in DevOps. You use it for automation, scaling, and updates. You can also decide to say the version, what version of a particular thing you want, or to update it, or to rotate it. Tools like Terraform, they track real-world states versus desired state. Let's say somebody went into your management console and created something. We don't know who that was. And you come and run your Terraform plan. Say, what's the plan? We'll tell you what the plan is. And anything that was created that wasn't your will is going to be destroyed. And what you wanted as defined in the Terraform, that's the beauty of it, is going to be created according to your plan, which means that your plan takes precedence over what is defined in your management console. I've talked about this already. We'll also talk about the resources. This is like how it works. I speak ahead of what is coming. So we have the provider block, which we already saw. You define the provider block. Instead of you having AWS here, you can have, instead of AWS here, you can have Google or Azure, depending on what platform you prefer. Instead of you having US West 1, you can have any region that you prefer. This resource could still be a database or a VPC, but the Amazon machine image must match. You need to go to the provider and say, what image does this particular resource have? You put it here. And instead of having a very small, for example, if you had this same resource, but instance type, you can come later and change the instance type from T2 micro to T2 large. It's going to replace what you had previously and take what the Terraform plan declared. So that's what they meant by it is declarative. Yeah. Yeah. The approach is declarative. You describe the desired state and Terraform makes it happen. So there can be version control. You can reuse it, you can share it, you can support it, and it also follows DevOps best practices. That's the beauty of infrastructure as code. Apart from Terraform, we also have Pulumi. It's also an infrastructure as code. We have Crossplane. That's when you're using several clusters and many more. Now, the next question we should ask ourselves is, how do we know what is happening? You have your cluster running, you have your nodes, you have your pods, you are using your Terraform, everything. So how do you know what's happening? That's when monitoring comes in. You have to continuously observe your application and infrastructure so you can detect issues early before they become an issue. All right. So what are we really observing? We observe metrics. And what are metrics here? Metrics are like the CPU memory, your request latency, and everything. You can also observe the logs. Logs are like timestamps, the records of what system happened. Let's say, oh my, um, at 10 o'clock, there was like a very high spike. Something happened that we like went up, and 3 o'clock it went down. So those are logs. You have to take out the logs and find out. But sometimes logs gives you but timestamps. But again, you want to have like details of what really happened. That's when you come like traces. You have to trace it. So traces are like end-to-end snapshots of individual request transactions that they pass through microservices, which are really micro. And also have like events and heartbeats. I work for a television for LTL. So all of these are things that every day when something happens, we're observing. We have to first check the metrics. Then we'll check the logs. And then we'll go detailing into the traces. So these are really processes that a whole department is in charge of monitoring. It's a whole thing. So yeah, these are tools that you can use to collect and store data. For the metrics collection, if you're on AWS, you have like the CloudWatch, which collects watch metrics, sorry. And it's built in AWS. Sometimes we also have like Prometheus, which is like an also open source like, which means if you want to you want a more detailed analysis of what's happening, you can export your CloudWatch metrics. If you're using AWS and all your clusters are in the AWS, you export all of those metrics, the logs, and the traces. You export all of them to Prometheus. And Prometheus is like a time series metrics, and it gives you more details of what's happening. You can also use the ELK, Elasticsearch, Logstash, and Kibana. That is ELK, CloudWatch logs, and everything. You have Jaeger, we use for tracing, Zipkin, we use. So there are a lot of open source tools that help to give a deeper understanding into what's happening in your infrastructure, which is running on a different platform. So Jaeger, Prometheus, and ELK are separate from cloud providers, but they can be integrated into cloud providers so they can extract the information or export the information. Also, after you have seen them, after you have the information, you need to also like visualize them on the dashboard. And Grafana is very good at that. You have Grafana and you have Mimia. These are all examples of high quality and detail oriented uh, real-time charts for key metrics. And now you want to be able to know what's happening when it's happening. So it is not magic. So that's when you need to integrate alerts. So you use something like Alert Manager and CloudWatch Alarm, which means you define service level indicators and service level. I keep forgetting the O. So these are all um, principles, not principles. These are all defined parameters that you define that if the memory is above, if the consumed memory is above 70, please fire an alert. And when the alert fires, somebody's phone is going to ring. And your phone can ring because you integrated your service with Slack, with OpsGenie, or PagerDuty. You can even do Teams. Integrate it with Teams, and your phone is going to ring, and you say, okay, your phone is ringing because this alert fired. Why is it firing? Because the consumption was above 70 as we defined. Then you go in now, you check on your Grafana to visualize it. Oh, actually, it was above 70. Then you go back a step back and say, all right, it's above 70. Let me check on the metrics. What happened to the CPU? Then you go now to the logs. Oh, at this particular time, what happened? Why is it so? You see that it is a chain of reactions. You can go forward, you can go backward to trace what really happened, and you take measures. And the good thing is now we are back again in the monitoring. If you monitor and see that, oh my gosh, we did not, we gave really a limited amount of memory to this application, we need to go and increase the provision. What does that mean? It means you need to go back again to your source code and increase the CPU. You say, okay, I don't want it to be 100, I want it to be 250. And once you make this change, you have to use Git. You go now to your source code, you pull it down. You pull your source code down into your local machine because you can't do this remotely. You have to pull it down to your working directory, which mine is VS Code. In VS Code, I create a branch. I said, this branch is increased memory. That's how I'll name the branch. And I go ahead and increase the memory. Once I've increased memory, I add the change. I commit the change. When committing the change, you need a commit message. You say, okay, what does this change imply? You can write a sentence, increasing memory to this capacity is high. Then you push the change now. When you push it, it goes now to the building stage. It builds, then it tests, you release it, you deploy it, and everything. So the CI/CD pipeline goes again because the monitoring alarm fired. Now, where are we? Yeah, okay. Well, let's be. The next slide is about automation, automate remediation and feedback. Why do we do auto scaling? Why do we have self-healing? Why do we do incident tracking? And what is post-mortem? So assuming you needed to auto-scale, you have auto-scaled through Kubernetes, because Kubernetes is good at auto-scaling, and there's a whole deployment called, no, not a whole deployment, there's an object. Kubernetes has a lot of objects. The object it can be a deployment, can be a pod, it can be a replica set, it can be a daemon set, it can be a service. Those are all objects in Kubernetes, which is a whole topic on its own. I'm just giving you level 0 knowledge here. So when all of this happens and you see that, oh, I've tracked my incident tracking, something happened, I did the correction. It doesn't end there. In DevOps, it's very, very important, a culture and collaboration. Two, like documentation, because it's a continuous improvement. That's DevOps. You have to continuously improve, which means when something happens, you document it, which is called incident tracking. You track the incident. And postmortem in our company, we have postmortem on Mondays, where you come and talk about everything that happened, the mistakes that occurred, how you solve them, and what lesson has been learned from it. So this is like a whole thing. Now, let's close the loop in DevOps. What does that mean? So we have like developers, the instrument, the CI/CD pipelines, the operation, and the teams. So the developers, they like use code with metrics library and structured logging. CI/CD pipelines, they run synthetic tests and push test metrics into the same monitoring system. Operations, this is just a little bit of information on what each particular domain does. So developers, they deal with the code, right, in the building stages. The CI/CD pipeline actually runs the job. The once the code is ready, what do? You have to run the job, take it from there through the different steps, the CI, the CD, you integrate and everything till when you have the end operation, which is good for monitoring. You have to monitor it then. Operations is like continuously monitor, check real time traffic because it's really operating. They have the daily operations. Let's talk about the tools. Then you have the teams, the review monitoring feedback in retrospectives, refining alerts, dashboards, and code to improve reliability. And this is done through, as we said previously, we have the post-mortems, you have the incident tracking, and the rest. So, what tools do the development team use? You have the version control, which is Git. You have Git CLI, you have GitHub, you have GitLab, you have Bitbucket. These are all repositories. GitLab, all these three are repositories. And you have like the static analysis. These are all tools, testing frameworks. Yeah, Selenium I used one time, but our testing framework, we use Python most of the time to test new tools or to test a process. Use Python. And for the operation, which is like the operation is part of the CI/CD pipeline. The most common tools are Jenkins, GitLab, CI/CD, GitHub, Circle CI, AWS. If you're using the AWS management console or the AWS platform, then most people prefer to use third party tools such as GitLab, GitHub, and the rest. You can still use AWS. So this is just it limits you to AWS, but this is open source, which means you can integrate it with many other source codes. And infrastructure as code, we have Terraform, which we talked about very briefly. AWS has their own infrastructure as code called CloudFormation. We'll talk about Pulumi, and then you have the AWS SDK software development kit. And to configuration manage to configure management configuration, we have Ansible, Chef, Opé, Salt Stack. I don't know which one you all use. And for your container, you have the Kubernetes all the way. If you're using a Kubernetes in AWS, it's called EKS. Kubernetes in Google is called GKE, and Kubernetes in Azure is called AKS. Sometimes when you're going for an interview, they'll tell you that we're looking for a DevOps engineer, but mostly for operations. So what does that mean? It means that you should be like a guru in monitoring. Because the operations means that you're continuously monitoring. There is a certification for Prometheus. So Prometheus has its own course, and you have to be good with Grafana, creating dashboards and the rest, using Datadog, New Relic, Amazon CloudWatch, know how to massage data, know how to find the logs, use tracing, open tools like FluentBit, Jaeger Agent, and all of those for logging and tracing. You have Loki, that's Fluentd and the rest. Alert management, you should be sure that you're able to understand what an alert is. how to read an alert, and how to silence the alert or create more alerts depending on the use case. So this is where the operations part of DevOps comes in, is to make sure that they really identify the changes or look at the code or the repercussion of the application and says, look, this is what we found out. These are the changes that need to take place. So take this code and adjust it. Then you go back now to the planning stage and start again the CI/CD from all over again. So yeah. Then you also have like operations are really good tool for security. But again, as a best practice, it's good to incorporate security from the beginning through Terraform. You can really like scan your code. Start from the beginning, scan the code for vulnerabilities before you even inject into your CI/CD pipeline. Or you can have some add-ons that actually do some security scanning. You don't want to to have a bug in your code, like it can mess up your whole system. Then there's also like the service mesh. Service mesh is advanced. Yeah, you have Istio, you have Linked, you have Consul Connect, but we'll deal with Istio. This is advanced knowledge, which means that it decouples some services. It decouples some services and and brings them into your application as a sidecar. Yeah, this is a little bit high knowledge, but anyone who knows about Istio is going to appreciate this. So Istio is also a great addition to your application lifecycle. Now, are you all there? We have like, it's taking longer than I thought it will. I hope that you all are getting a little bit of understanding of what DevOps is and what DevOps entails. DevOps is really broad, and each day they keep incorporating new aspects of it. So yeah, that was it for the presentation. And do we have any questions? Um,
Okay.
I want to like update it, the last slide. Give me a moment, please. No questions? All right. So the next slide is talking about, oh, what's happening? Yeah, it's talking about me and, oh, okay. Let's go to the very, very last slide. Thank you for listening to me. And this is my profile. That's where I work, and that's my LinkedIn. Thank you so much. And I wanted to talk a little bit about the way forward for those of you here who are new to cloud computing or really new to DevOps and the ecosystem. There is the Mentorship Matters Africa movement that we created. So you can follow us. This is really is dedicated to empowering students, new graduates, young professionals, career switchers, and underrepresented candidates in the tech industry. Because this cloud computing it can be intimidating, it can be overwhelming. So you really need also somebody that speaks your language. When I was learning cloud computing, I learned from a platform where I needed to reduce the speed to like 0.5 because I couldn't understand them. So if you are with someone who really knows your culture, understands you, understands the limitation of what it means to live, let's say, in Ethiopia, with the life struggles. Because some people say, "Oh, I understand," but they don't really understand. They don't speak the language. So, Mentorship Matters Africa is mostly for the can I say underdog, somebody that is not even sure of yourself. Because I wasn't sure of myself in the beginning. I was like saying, "Oh, I can't do that. Tech is for men. Oh my gosh, it is so hard. How will I do this? I have children. I'm a woman. I'm a wife." So to like get that, shift your mentality first of all. Get your mentality straight before you know what you want and how to start. Some just come and just start learning cloud without cleaning the house. You have to sweep the house, your mental mindset, and continuously, yeah. So that's what Cloud Heroes Africa is all about. We like start from the beginning, even if you don't know who you are, which I find together we are on a journey together to like empower everyone. Everyone. We mostly have women now, but if you think that is something for you, you are doubting. I want to be a DevOps engineer. Or you might see what I've done today and say, "Oh my God, it's so hard." No, I'm changing my mind. I'm going to go and do cybersecurity. When you go to cybersecurity, you say, "Oh my God, it's so hard. Oh, I'm going to do cloud engineering." You just find yourself being an academic prostitute, right? Going from here and wasting time. AI is taking over. You're wasting time. So just like find out what you want to do and understand that it's going to be difficult. Find your people around you. Those people that will tell you the truth, whether you hurt or not. Tell you the truth and be brave enough to tell you that. So that's what I really believe that will help us more on this journey. It's not the end. I still struggle with certifications. I've, I've found my superpower. um it is not easy, but it is worth the journey. So if you're interested, these are the links. And actually, before I joined this, I was like grilling for my family. So what I will do is I'll need to update the last slide. The last slide are like people you should follow, communities you should follow, be very cautious. I'm really very cautious on putting several links because they are distracting. They're very distracting. You just need to find out first of all who you are. Have two people that you follow. I always encourage Tech with Nana, if anyone knows her. Tech with Nana for DevOps, and I always say Tech with Lucy. Lucy, she almost like she talks about the AWS arena. I listen to her a lot. I taught myself cloud computing by listening to people. So I wish I had me then. So yeah, so yeah, that's it. That's what I have in store for you all today. I'll just look for two more links and I'll provide it. I'll make it accessible to all of you. I'll work on it again and find just a few more links and post them here, leave them here. And this is my contact. I'm on LinkedIn. DM me if you have any questions or doubts or support you need. So that's it from my end. Thank you all listening to me. Excuse me. Yes, please. Yeah.
Okay, thank you so much, Endah, for giving us this chance and also sparing your precious time to spend this session with us. I feel like I haven't introduced myself formally. So, my name is Hildana, and I am a member of the WTM team, and I'm a co host for today's session. So, that's why I'm taking over now.
Okay.
I would like to start off by saying it was a very wonderful time. Honestly, you were the guest, but you made us feel welcomed and relaxed more than enough.
Oh,
And this session was, it's just, as you said, it's not something that we'll get like overnight, but it was like you planted a seed. Somehow, if we encounter these situations or like these type of sessions, somehow it will click over time, but it's not something that's gonna just, we're gonna get it over like overnight. So it was a very amazing session. Also, I would like to mention the fact that you talk about like a mentorship, and that just goes with the idea of WTM as well, because like the WTM, especially this session, was created to like people out there that don't know what they're doing or like don't have a specific idea of like they're not sure of themselves, it's like to give them a brief look of like, oh, this is what it looks like, and you're not alone. So like with these sessions, we're trying to create this welcoming, and also anyone can do it. Like you said, just because you're a mom, just because you're a woman, nothing is like gonna hold you back. So I feel like I like the fact that you also struck our goal as a WTM members. So I would like to thank you for that so much. And if anyone else doesn't have any other questions, we would like to let you go. And thank you so much for your precious time again. And we will link up her LinkedIn and other social medias as well so that they can contact you. And it was a great session. And for the rest participants, I would ask to stay after we let you go. Thank you so much for your time.
My pleasure.
Yeah, okay, Ida has raised her hand. You can continue.
All right. Inda, thank you so much for being here. It was really an incredible session. Also, there is one statement that most of the developers are scared of, and that is, but it works on my machine, right?
Yeah.
So I would like to thank you for clarifying that also. It was an incredible session. I'm happy to have you here.
Oh, my pleasure. I'm glad that I had the time. I've thought it's overwhelming, so much information, so many tools, because DevOps is no joke. You
Yeah.
have so many integrations. So just to understand the principles on why in the first place, that's the first step. If if for any reason you found the tool so overwhelming, please just understand why DevOps, right? Think of the waterfall. Waterfall was so manual. Went to agile. Agile was also like its own thing. So DevOps was really like the way to go for simplicity and automation. So yeah, I'm going back into my slides to know. Let's not do that. So yeah, thank you all for having me. I'm glad I created an impact. So that's it.
Thank you so much. Thank you for your time.
You're welcome. So these 14 members, are they so shy? I wish I could just bump into your living rooms or wherever you are. That would be real, right? Just imagine me knocking on your door. Why didn't you turn on your video? That's what I'll ask you. All right, I don't know what to say now. So who else can come up? I want to look for trouble. I'm a troublemaker. Um, Misa, Misa, help me. Misa, Misa. I don't know. I'm calling it right away. Naomi, Naomi S. Kinder. Oh, is that a German name? It sounds like German. S. Kinder. Okay, no worries. I'm going to mind my business, me. Okay, ladies and gentle. I'm not going to give the men the honor if they not show up here. So,
Actually,
late.
as an audience, we're programmed to be shy,
Hi,
but of course.
Naomi! Naomi came up! Yay! It worked. Oh, yeah. Aida, you saying something about the men? What did you say?
Oh yeah, I was saying as Ethiopian, we're programmed to be shy, I think, but
Oh,
I'm pretty sure they will contact you in your LinkedIn.
your program to be shy. Oh, my God. I thought
I
that
think
program
so.
would have failed on me woefully because I'm not. It's not for me. Hi, Naomi. What's up? Are you switching off your mic? I can't hear you. Ah, okay. You can't speak. All right. I'm glad to see your face, though. You're very pretty. Okay, let me find some more trouble. Who else can I poke? Mm, oh, negative, negative, negative. Please just come before I butcher your name. Negative. Come on, correct me. Come on, correct me. Negative. Tech, tech layers. Wow. I'm calling it very wrong. I know that. So please. Negative. Come on, correct me. Ah, Temima. What? So beautiful names. And just hear my name, Indah. Just hear Indah. Just like that. Indah. Temima. Nice. All right, ladies. I don't want to keep you more for such a long time. Thank you. It was a pleasure. We need to get a photo. What about the picture? No picture? Oh, you did already.
Screenshot.
Oh, you don't do that? Are you programmed not to take pictures too? Should we take a picture? Are you okay with
Of
that?
course.
All
Yeah,
right.
so,
Okay. I just did one. So anybody who was not on this picture is going to gain 5 kilos.
Should we all say peace?
Yeah, sure. Sure.
Okay, in three. One, two, three.
Who's taking the picture? Because I need to go back.
I thought you were gonna take the picture.
Oh wait, okay. You do the peace sign, then I'll take a picture. I'll just smile.
Okay, three. One, two,
Yeah, good.
three.
So
Perfect.
I'm going to send a picture to Meron because I have her WhatsApp, or just send it to her on LinkedIn. So yeah, I'm going to go now. I can be here for the whole day. Bye, ladies.
okay,
Thank
thank
you
you
all.
so much.
Bye.
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 Okay, thank you everyone who attended. I am gonna attach a link for attendance form. So
Kilgan, I think you're muted.
my bad. So I've sent a link for attendance form. So please fill that in the chat box, and I will also be attaching a link for our social media. So please follow us on every social media. And thank you for this session. If you have any feedbacks or comments, please feel free to let us know. If there's nothing else, I think that will be it. Thank you so much. Yeah, this meeting is recorded, so you'll find it on our YouTube channel as well.